Hey guys, welcome to our comprehensive crash course on building and deploying a basic food delivery application, which is a basic MVP, that is a minimal viable product with the basic functionalities implemented using Angular and microservices. In this exciting journey, we will take you through the entire process of creating a robust end-to-end solution that combines the power of Angular for front-end development and microservices architecture for back-end developments. But that's not all. We will also take you to the exciting world of continuous integration and continuous deployment. That is CI/CD, ensuring that you not just create your application, but also deploy it seamlessly and efficiently with all the automations implemented. Now, our journey starts with creation of the microservices that lays the foundation of our backend application. So you can see here, this all is a part of our backend application. We have designed 4 dedicated microservices, that is restaurant listing microservice, food catalog microservice, user microservice, and order microservice. These microservices all work in harmony and cater to different aspects of our food delivery application, ensuring efficiency and scalability of our backend application. Now, to guarantee the data reliability, performance, and high availability of this food delivery application to our consumers, we seamlessly integrate the managed AWS services into our architecture. So if you can see, where do we deploy all these microservices? We deploy in AWS. By using the AWS as the cloud platform, we essentially recreate the real world experience of developing an enterprise level application, that is food delivery app. Our relational data exists on Amazon RDS for SQL, while the NoSQL DB data resides on MongoDB Atlas. This ensures proper data management, storage, and retrieval from relational as well as the non-relational DBs to our microservices. Not just that, when we create these microservices in backend applications, we must adhere to some code quality checks and unit testing. We are not going till system testing using DDDs and all, but at least we have integrated the JUnits and Sonar checks to ensure that our code base have comprehensive code analysis and it helps in maintaining the code quality throughout the complete development process. Now, once everything in backend is developed in local, we need to move to the deployment, right? So moving to the deployment, we have adopted Docker to encapsulate our application, enabling the seamless portability and consistency across multiple environments. Our application now is containerized with Docker, which actually resides in AWS EKS. So you have Dockerized, that is fine. But this Dockerized application has to reside in some Kubernetes cluster, right? So we are not creating our own Kubernetes cluster and managing it. We are using the AWS managed service. A managed Kubernetes service that streamlines the stability and orchestration, which is given by AWS to us. So AWS EKS is used for deployment of these Dockerized microservices application to AWS. For that, we have used AWS EKS clusters. Not just that, we need to ensure high availability, smooth traffic routing, and for that we have incorporated the power of AWS load balancers, which actually acts as an entry point to the complete whole food delivery application. This intelligent load balancer optimizes the routing, thereby preventing the bottlenecks and delivering a real-time user experience by actually balancing the load between multiple pods we have created. Now, not just that, till now we have covered the deployment part, but our journey doesn't end with the deployment. We actually believe in the power of automation for the maximum of efficiency. So there comes the power of CI/CD. So we have all this code that I have shown you in the previous slide in the local. Our task is now to use GitHub and push everything to the remote repository, and from there the CI/CD pipeline should be created to actually deploy it in the EKS cluster that I have shown you previously. So here comes Jenkins for CI, which is actually deployed on AWS EC2 instance itself. So in this journey, you will also learn how to create an AWS EC2 instance and deploy Jenkins over it. Jenkins takes charge of building and testing our application, making sure that with every code push that you do in your local to the remote repository, it goes through all the Maven build, quality checks, everything before getting deployed on your Kubernetes cluster. And once you have the proper manifest file updated, there comes the task of Argo CD, which is continuous deployment tool. So for continuous deployment, we have chosen an Argo CD, which is a robust tool that automatically delivers new code to the Kubernetes cluster, guaranteeing the seamlessly updates available that you are doing in your local is available in your Kubernetes cluster. Now let me make you go through the Udemy course sections one by one so that you know what we have done from scratch. So we have started by creating the backend for our food delivery application. Before just starting over the microservices, we have created some basic tutorial for what is Spring Boot, what is REST, what is RESTful, what are REST resources, URI, HTTP methods, features of RESTful web services, statelessness of REST that we have used, which databases we have used for our microservices for designing. So all these things are from the design perspective. Why did we use Spring Boot? Why did we choose REST APIs? Why did we choose relational DBs for food delivery app, restaurant listing and user service? And why did we choose NoSQL DB for order service? Also, why did we choose microservices and not the monolithic application? So we have given all the design documents here, why we have chosen and what is actually these all about. Also the Eureka server, all these becomes the part of microservice architecture only. And once that is done, we have started creating our restaurant listing microservice, food catalog microservice, order service and user service. These microservices are created end to end with all the database connections also, to make it run in local. So at the end of this section, you will be able to create 4 microservices and Eureka, and which is working properly fine in our local machine. After that, to create a full stack application, we also need a front end, right? For the food delivery application, here is the basic architecture of Angular application. So we will first see what is Angular, what is TypeScript, what is Node.js, why we are using Visual Studio Code, what is package.json, what is service and dependency injection in Angular. So basic theory and architecture is here. Then we start with the coding part. So here we have shown you wire mocks. Wire mocks are those screens that we are actually going to create with the code. So these are just the wire mocks and not the real screens. After that, we have started creating pages for our Angular application. The restaurant listing page where you can see all the restaurants listed properly. After that, clicking on one of the particular restaurant, you should be able to see all the food catalog. All the food items that particular restaurant offers to you. On clicking food items with the quantity, you should be able to get redirected to the orders page. And from there, you should be able to create an order. So that is everything. All these pages are created here in the third section for you. So by the end of 3 sections, you will be able to create a full stack food delivery application with front end and back end in place. And which is working perfectly fine in local also. Now your code is perfectly ready for the local application. Perfectly ready in local. Now we need to do the deployment to AWS. In AWS, as discussed, we were going to use AWS EKS cluster, that is a managed service by AWS, to deploy your application on Kubernetes. Internally, Kubernetes uses the Docker container, and Docker container needs the Docker images. So in section 4, we have seen everything about what is Docker, what is Docker file, what is Docker image, what is Docker container, what is Docker hub, why do we need Docker, how to Dockerize your front end as well as back end application so that it can run seamlessly in a container in Kubernetes EKS cluster in AWS. After that, there is a small section where we have done the profiling, because till now we were running our application in local. Now we need to run it on dev and prod. So multiple profilings have been done so that updated code is pushed to Docker Hub as an image. After that, we know that we need to create an AWS EKS cluster. So we have seen some introduction to AWS, some introduction to EKS, and how to create an EKS cluster in AWS. Then we have created the databases in AWS. So we have used AWS RDS for relational DBs, and we have used MongoDB Atlas for NoSQL DB for our order service. After that, we need to create and run our applications in EKS cluster. For that, we must know Kubernetes. So this section number 8 consists of Kubernetes theory, What is Kubernetes? Why Kubernetes? What is node? Types of service? Config map? What is secret? Difference between them? What are volumes? Replicas, deployments, stateful sets, and how to create the manifest files. With these manifest files only, you will be able to create pods in EKS cluster. So everything is shown in these two sections. Once you have successfully created your application in local, which is up and running in local, you have successfully created your Docker file, you have successfully created your manifest file, and your code is completely ready, then you should push it on GitHub, because from there only we will create a hook for our CI/CD pipeline. Because whenever you push to GitHub, there should be an automation to take your code from GitHub and deploy it on EKS cluster, which is on AWS. To automate this process, we will be needing our code to be deployed on remote somewhere. So that's why we have used GitHub. Not just that, we also need an entry point to our food delivery application. The front end will be the default route, and everything next should be routed based on the URL. So for that, we have used the load balancer from AWS, that is ALB. So we have seen what is load balancer, types of load balancers, what is AWS load balancer, what is controller and enclase, their deployment steps, and how to deploy the AWS load balancer and controller so that it can behave as a routing and an entry point to our front-end application. After that, before starting the CI/CD pipeline, you know that we need to have the proper code quality checks. To make our code JUnit testable and the proper quality checks and coverage should pass, you should implement the JUnits. So in this particular section, we have seen how to create JUnits. What is JUnit? What is mocking? What is inject mock, importance of Mockito, and how to write JUnits for our controller service and how to mock your repositories. Everything is covered in this section, and after this section, you will have your code completely ready and it was ready for CI/CD. So after this, we need to implement Sonar, which will be embedded into Jenkins, and where we will be creating the Sonar installation and configurations in EC2 instance. So with this section, you will be able to see how to create an EC2 instance in AWS and how to install your Sonar and other configurations in that instance. After that, you will also be able to see the CI/CD in real time. We will see what is CI/CD, what is the configurations that you need for Jenkins, how to create a Jenkins pipeline for one of the particular microservice, that is restaurant listing. Then we will see what Jenkins file is all about, because we need that Jenkins files which will create the pipeline in the Jenkins dashboard for you. Then we will also have to see how to create the CI/CD for Angular application, which is different from the backend application. And at the end, we will see how to deploy it using the Argo CD for the deployment. So with this, it completes your whole circuit, where we have started from creating a code in local machine, where we have all the backend and front end created with everything in place, then using the CI/CD and deploying it on AWS. So with this course, even if you are new to Java or Angular, you will be able to add all these technologies in your resume, which includes REST and RESTful web services creation. What is Spring Boot? Why Spring Boot? What is microservices? Why microservices? Why not monolithic one? What is Angular? What is the architecture of Angular application? How to create an Angular application? What is GitHub? How to use GitHub for your CI/CD implementation using hooks and all? How to implement JUnit and Sonar checks to make your code unit testable and to pass the code quality checks? How to use Docker in your application? Kubernetes? How to deploy your code to AWS EKS? How to create an EKS cluster? How to deploy on it? How to create ALB, how to create an EC2 instance and deploy different things onto it, how to use AWS relational database, that is RDS, MongoDB Atlas integration with your AWS, Jenkins for CI and Argo CD for CD. So basically, starting from top to bottom, you will be able to see multiple full stack technologies being covered along with the DevOps using CI/CD. With these technologies in your resume, you will have a very strong profile for a full stack developer. And this is a very small crash course, and in very small amount of time, like in 11 hours itself, you will be able to complete the whole course end to end. So even if you have an interview in 2 days, you will be up and ready. So our curated crash course doesn't not only teach you how to create an application, a full stack application, but also showcase the daily task that an experienced IT developer do in the real IT world. From front-end design of microservices to testing, to deployment, to CI/CD, you will get a complete insight into the life of a professional developer in an IT world. So if you are ready to embark this journey into the realm of the modern application development, please join us in this crash course. Learn, create and master the art of building a full stack application with microservice architecture powered by AWS, Docker, Jenkins and Argo CD. Thank you for tuning in. We will be seeing in the first module of our crash course. Thank you.